All right. Welcome everyone to yet another interesting study series. Welcome everyone. We know that from chat we can see people have not yet joined us. Maybe they're still trying to catch up, prepare up, and finish up with what they have going on. But we'll start regardless, since this is a class that anyone can catch up with at their own time. So we'll still give maybe with 2 to 3 minutes to know if more people will join us. If you can hear me now, do well to invite your friends. Tell them that we've already started, so that they can join us as we have a very interesting session. I know you missed us. We've also missed you too. So welcome back. We had a swell session today, and we are back with another session today. So in 5 minutes time, we'll be back. Let's hold up, listen to the interesting music we have for you. All right. Welcome everyone. Welcome back to our study series. We hope you enjoyed that little music. We hope you took the time to shake off, to settle down, settle in, get right today. So, as you can see, on today, our topic is an overview of quantum computing, how to build with Amazon brackets. I have little knowledge of this, but we have a very great speaker who will do justice, help you to understand what quantum computing is all about, tell you all the jargons you need to know about quantum computing and how amazing it is, and all what you can do with it. If I were you, I will ensure I get my pen and paper so that I can write down or jot on my phone or jot on my computer and then be ready to ask questions as we go along. Without further ado, I will welcome to stage one very special speaker and the person of Samuel Modupe. Hello, Samuel. How are you?
I'm fine. I'm good. How are you too?
We're fine, 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 fine. It's good to see you today. How
Same
excited.
here.
How is the weather in your place? How is it in your place? You can see you smiling. Ah, God, when oh, that's the kind of person you're putting us on.
Yeah, doing good.
All right. How is it on your end? What's the weather like? Where are you joining us from?
I'm joining from Lagos. I'm here in Lagos. Just where I am is a bit cold.
Oh, that's awesome. You see, his body is in Lagos, Nigeria, but his mind is outside Nigeria. His mind, I don't know the other way around. I think his mind is in Lagos, Nigeria, but his body is where there is snow. And that's why he's all cracked up like this. So, without taking much of our time, let's dive into what we have today. So, over to you, Samuel, and the slide is coming up. Thank you very much.
Okay. Thank you. Okay. So thank you very much. Let me share from my end because there's a part that has to do with demo. So I don't know if you can see my screen. Yes. Okay. Let me just go in straight into it. So my name is Samuel Modupe. I'm a CISSP. I'm also a contributor on AWS technologies and services. So the topic is overview of quantum computing build with Amazon Braket. For this session, we'll just be having an outline. We'll be looking at an introduction to quantum computing, what's Amazon Braket, what are some of the key benefits, what are the use cases, and also be having a hands-on walkthrough of this Amazon web services. So, what is quantum computing? I believe each and every one of us on this call must have heard about it, or if you're a science student, you might have heard about quantum physics. But what truly is quantum computing? It's a multidisciplinary field that comprises of aspects of computer science, physics, mathematics to utilize a concept which is called quantum mechanics to solve complex problems, and it's faster than the classical computer. The computer you and I use today is built on zeros and ones. You have the CPU, you have a memory, you have a RAM. So that is the classical computer we have. But when it comes to computing, there's a new paradigm that has to do with quantum computing. It changes the basics of how we see computing. Now, it has the potential to solve computational problems that are beyond the reach of classical computers. One of the advantages that cloud gives you, like AWS, is that you're able to pool resources and you're able to run massive workloads. But with quantum computing, you can do even beyond that, beyond what the power that the cloud can give you. You can actually process more than that. And it's a field that has to do with application development research. And there's also a definition of quantum physics, which is an area of physics that talks about particles and microscopic level. When you compare quantum computing or a quantum computer and a classical computer, they are miles apart. While it takes a classical computer to complete one computation, mathematical computation, for a quantum computer can do a million computation at once. So is a game changer. Now, one of the best way to explain the difference between the classical computer and the quantum computer is for you to see the candle and the light bulb. You would see that the light bulb is not an enhancement to the candle. It's a totally different paradigm. While one is powered by candles, while the other one is powered by electricity. So computing is a different paradigm entirely. In classical computing, we know of bits, zeros and ones, electrical nodes, zeros and ones. But in quantum computing, we're talking about quantum bits, which is called qubits. And in bits, it's either a one or a zero. But in quantum computing, you can have combinations of zeros and one. You can have what we call superposition, meaning that you can have one and zero simultaneously. And the best example is like the coin where you have either head or tail. In quantum computing, you can have both head and tail. So it gives you endless possibilities and permutations when it comes to it. And it also relies on probability. So this is also an example here where you see bits of zeros and one, while in qubits you can have a qubit having both zeros and ones. Now, another thing also you need to look at in as a cloud security user group, we're also looking at what are the security implications of cloud computing, of quantum computing. With all this processing power, how does it apply? How does it apply to cybersecurity? What is the implication of quantum computing to cybersecurity? Now, when you talk about quantum computing, one thing that comes to everybody's mind is cryptography. Does it mean if you have super powered computers, all our encryption will be broken or will be decrypted? And that fear is valid. That is true, because in quantum computing you have to rethink encryption. Encryption is built in such a way that you're saying that the effort it will take to break that encryption can be millions of years, but with quantum computing it can be a day, it can be hours, even the biggest or the strongest of encryption technologies. So, quantum computing in cybersecurity will help us to rethink encryption and see how we can build stronger encryption mechanisms that quantum computing cannot break. And there's also an evolving field which is called quantum safe cryptography or post quantum cryptography that looks at how to create algorithms, encryption algorithms that are resistant to the effect of quantum computing. So that's by the side for cybersecurity. Now let's go to the topic of the day, which is Amazon Bracket. When you look at the powers of quantum computing, you would see that it is only in universities, government agencies, because the cost or the capital it would take to have a quantum computer can be very expensive. So, but what Amazon is doing, they are bringing that to you with a cloud model of pay as you go. So Amazon Braket is a fully managed quantum computing service on AWS that allows you to do your scientific research, to do your software development on a quantum computer, rather than having to spend millions of dollars or billions of dollars to build a quantum computer. You can actually use AWS to get the benefits you will get from a quantum computer. So it provides everything you need from building to testing on quantum algorithms on AWS. And it is secure, it gives you on demand access, and a pay as you go model, as we will see during the demo, where I'm able to actually leverage on quantum computing to make some computations. It also provides a software library or SDK, software development kit, which allows you to be able to develop softwares on Amazon Brackets using Python. And this supports researches and also helps the maturity of technology. Now, what are some of the key benefits? What are the benefits you get making use of this Amazon service, this AWS service called Amazon Bracket? Is that it can help accelerate scientific discovery with the researchers that are looking for more compute power to be able to do their permutations, do their combinations, do their research. Amazon Bracket makes it easy for them to leverage on the power of quantum computing, which would make their processing easier, makes their research easier. Another benefit is that you're using a trusted cloud provider, as many AWS cloud users here will testify that AWS is a trusted platform. It's quite very trusted. When you look at the engineering, when you look at the reliability, it's it it's the best. So with AWS, you can build quantum projects with simple pricing and management control. The pricing is wouldn't tear your pockets. Another benefit you also get is priority access. So, from the concept of the cloud that has to do with a shared infrastructure, you can actually share and have priority access to these quantum computers that might cost you a whole lot to have. So, you could even run what they call an hybrid quantum classical algorithm. You can leverage the power of AWS cloud with with this quantum computing power to be able to run more processes, and you have the option of a reserved dedicated capacity. Even though it is shared, you can have a dedicated capacity that you can use. And it also has what they call the bracket direct, where you can actually have a one-on-one session with a quantum computing expert that might guide you in your research, that might also assist you as you use the platform. So how does it work? How does Amazon Bracket work? One, it helps you in building. It can help you build quantum algorithms using a Jupyter notebook in your own development environment. You can use SDKs. You can also use the notebook that is available on the management console to build. You can test. It has a simulation environment where you can actually test your algorithms. There's a local simulator on AWS where you can test these algorithms and actually test all those scenarios. Then you can also run them on what we call a quantum processing unit. Just the way we know the CPU, the central processing units, there's also the quantum processing units that are on specialized hardware, specialized quantum computers. And lastly, you can actually analyze this. You have the option of having your results in a place in S3 bucket where you can analyze the results. So, what's the flow? The flow for quantum computing is simple, and the flow is this. First, as a user, on the management console, you create a task. What is a task? A task is you having to define the instructions of what you want to do. You writing a Python code that talks about the task you want to perform or the computation you want to perform. And that is done on the Amazon Bracket notebook, which is the Jupyter notebook. We'll be seeing that in our demo. Then once that is done, you submit it to the API. So you submit the task to the API, which then runs this task for you. And this task is run in a managed simulator if you were to use a simulated environment, or run it in a live environment, which you have the QPU, the quantum processing units. So after that is done, the result is sent to S3 bucket where you can actually reference the data or the result of that processing. And you also have integrations with AWS services like CloudWatch, like Event Bridge, where you can actually analyze the logs of what happened. So this is the flow of how Amazon Braket works. Now, what are the use cases? What are the applications for quantum for Amazon Bracket? What can I use Amazon Bracket for? You can use it for research. If you're doing a research in quantum computing, it's a best bet. It will make your cost of research cheaper because you're able to use the service on a pay-as-you-go model. So it helps accelerate scientific discovery with tools for algorithm development that supports your research program. Now you're also able to test quantum hardware. You don't have to spend so much to test the hardware. You can actually do this on the platform. It also helps to build quantum software faster because you have a simulated environment where you can actually test, and you can also run your algorithm. And it also helps to build open source softwares that are for quantum applications. So this is the general four use cases for Amazon Bracket. It has applications in medicine, in cancer research. There are so many use cases, but these are just four use cases that we have here. So the next is the hands-on demo, which will do a live demo of the environment of Amazon Bracket. So I'll be walking you through this environment. Okay, so you log into your management console. This is how your AWS management console looks like. And there are multiple ways to which you can access Amazon Bracket. If it was a service that you've actually visited before, you will have it here where you can choose. You could also come to services here, then come down to quantum technologies and find Amazon Bracket. That is one way. Another way is just come and do a search, Amazon Bracket. Mind you, the bracket doesn't have a C, that's how it's spelled. So once I go there, it takes me to the dashboard. Now, I want you to note that Amazon Bracket is a regional service. So for every region, you will need to activate the the service. So you have North Virginia is one of the services where you have quantum computing. You also have North Carolina, California. You have U.S. West. You have Europe. So those are the four regions that you have this service running at the moment. So I've enabled it on North Virginia, but let me just walk you through how it is if you were just trying to enable this. Okay. Okay. So when I go to dashboard, come on the dashboard. Okay. So I've actually enabled it, so that's why I'm not seeing it here. Okay. So on the dashboard, on the Amazon bracket, it gives you announcements or the progress that is being made as to the development of this project or products. It also talks to you about the community support, and you get to see the resources and active notebooks. When you come to devices here, it gives you a highlight of the quantum computers that you have. So you have three in AWS, which are local simulators, while you have seven other hardware providers for quantum computers, and it gives you a highlight of their availability and also a description of their processing power in terms of qubits. So you have 34 qubits, 50 qubits, 17 qubits. You have as much as 256 qubits in terms of processing power, and it tells you if they are available, if they are offline. So these are the devices you have that you or quantum computers that you can actually choose to run your quantum algorithms. The next is notebook. So you can create a notebook. So the notebook, if you remember from the flow I explained, that is where you create your tasks. That is where you do your programming. That's where you do where you develop your algorithm. So to create a notebook, you have to click create here. Then it asks you for a name. So I can give it AWS study series. So the next it tells me, because I've created one before, that's why it's creating it. Some will give you for specification that you want. So, but actually, it's creating the notebook. So just wait a while. So while that is running, I've created one before. Not Virginia. Okay, let me go here. So for North Virginia, I had actually created one, which had actually been done. So this was done today, earlier today in the afternoon. But I had to stop it because of billing. As you know, in the cloud, you don't leave things running. You need to use them based on demand. So I'll start mine. Let me start my notebook. So once the notebook is up, I'm able to create quantum algorithms and are able to run them using that. Okay, so while that is running, you have the options of a hybrid job. Now, hybrid job is you wanting to leverage both the cloud computing and also the quantum computing. You can have that usage, both of them working together. So that is where the hybrid job talks about. Then there is a quantum tax. When you run a tax on a CQPU, mostly when you run it on the hardware, you have them identified here. And you also have the algorithm library. So you might want to leverage on some other people's work on GitHub on quantum algorithms. So this is one with a reference to GitHub that tells you where the algorithm is hosted and the contributor. You also have different algorithms that you can leverage for based on your use case or research you want to do on quantum computing. Secondly, you can look at the um, Braket Direct. The Braket Direct is a service that allows you to reserve a device and also have a one-on-one engagement with. So you could have one-on-one engagement. You could also connect to hardwares directly. So these are the hardware providers. You have IonQ, Oxford Quantum Circuits, Q-Era, Rigetti, and also the Quantum Solution Labs. AWS has a Quantum Solution Labs, which I would show you. You can actually collaborate with them to develop quantum algorithms. Okay, so let's go back to my notebook. Is it up? Okay, it's still pending. Okay, so let me walk you through the devices. Now, for the devices, you can go through each one of them. It gives you an highlight about or information about it. So this is a local simulator in AWS that allows you to simulate. It gives you an idea about it. They have names like SV1 is a fully managed high performance. You have you have this level of information about them. IonQ, so IonQ is down. You look at I think area one since it's available. You can look at calibration. This calibration speaks more into the processing power of this device. You have native gates. Um, so this just speaks to the devices. Let me check. Okay, let me check this other one. Okay, maybe I might need to just sign out and sign in again. Just a sec. My notebook wasn't coming on. Let me sign out of let me use my MFA. It's best practice to have MFA on your management account. Mm, Apologies, I'm having issues logging on. Okay, I'm back. Let me see if my notebook is back up. Okay, so notebook is running in North Virginia. Let me check. Started two notebooks. Okay, both of them are running. So I had to just sign out and sign in. It happens when you're doing a demo. Okay, so to have access to the notebook, you click on this URL. This URL will take you to another web page where you have access to the notebook. So the notebook looks like an IDE where you can actually develop um, quantum algorithms. So this is a notebook. The beauty of the notebook is that you have examples which we can play around with. Yeah. So let's play around with the get started one. So this is a get started notebook. So this get started notebook just gives a highlight of on an algorithm. It's just a tutorial algorithm which you can actually run. So let's just run this one, and running this very particular notebook should give us a result like this. So this is what I expected result should be um, at the end of it. Okay, so I will create a new notebook, um, container bracket. Then I would run each of these command, run them. So the first speaks to importing some libraries. Second speaks to building a circuit. Okay, it's building the front catch. This may take a moment. Okay, while that is running, let me run other ones. Okay, the next one is this, which is submitting it to the local simulator and updating results. Okay, then okay, this should give us the result in a graphical format. Let's see. So we have our result, our computation results. So this is what we get after this computation. So what we've done here is that we've leveraged Amazon Braket to create a task on the Amazon Braket notebook, which is the Jupyter notebook, and we've run quantum algorithms on a local simulator to give us the results that we need. So this is how this is just giving an overview of the service and what it can do. So I also want to point out that you should turn off the notebooks because of the cost implications that is there. So let me turn it off. I'll turn it off for the North Virginia region and also for this other region I created a notebook for. Okay, so that is the end of the hands-on lab. So also just use this opportunity for if you want to do more, you can actually engage Amazon Quantum Solution Labs for um, more labs on those products. Yeah, thank you. So I don't know if there be any question for me. Thank you. So hi blessings. I don't know if there's any question.
Hi, can you hear me?
Yeah, I can. I can. I can.
Sorry, I had some network glitch. Thank you so much um for the awesome presentation. Okay. Let me see if we have questions. Guys, if you have questions, this is the perfect time to ask your questions. Or did you get any question before now, Samuel?
No, I did not.
Okay. Let me check the I don't see any question. Oh, okay. Thank you to Sophie Sifokazidolo. I hope I got your name correctly. We are happy to have you on the session and we're super excited to see that you got knowledge, you got insights too, yeah. So thank you very much. I hope that you will join the next study series coming up in 2 weeks' time, most likely. Okay, so if you have any question, this is the time to ask before we draw the curtains. We won't be having quizzes today. There'll be no quiz today. So we'll just take questions and answer and then we'll wrap it up for today. Let me wait for a few more minutes and then if there are no questions, then we can just wrap
Thank you.
it up for okay. Mm-hmm. Oh, I got the name correctly. Yay. I guess that's a sign for me to visit South Africa. Okay, beautiful. Thank you.
Yeah,
Samuel, why are you laughing now? Or do you want to join me? We can go together.
yeah. I can be your.
All
I
right.
can be. I can join your entourage.
All right. Okay. Okay. I guess there are no questions, so that is good. You can always come back to these recordings. That is the beauty of what we do here. So if for example you are having a conversation with someone or you're even working, doing a project or an office work and then you remember something that has to do with quantum computing, you can always come back to our page, check through the video again, see how Samuel did what he did. And of course, by then, if you have a question, you can definitely ask in the community WhatsApp group. We'll have people that'll be happy to answer you. People like Samuel that'll be happy to, answer you. So Yes. Thank you once again, guys, for joining. We look forward to seeing you in the next session. Do have a lovely evening, and we wish you the best of the days left in the week. Cheers,
Yeah.
guys.
Yeah. Thank
And
you,
thank you,
everyone.
Samuel. Thank you, Samuel. So much. That was incredible. That was incredible. Thank you so much for the insights
You're
shared. We
welcome.
couldn't have done this without you. And of course, we look forward to future sessions with you, obviously. Thank you,
Yeah.
Samuel. Have a beautiful evening.
Same here. Bye. Cheers, everyone.
Bye. Yeah, cheers.